Hi guys, so I'm not going to show my picture today so that I can have maximal writing screen for you. So we've been talking about two-way designs, and two-way designs are ones where we have x1 and x2, two independent variables, and you can see here we have a minimalist two-way design. It's a 2 by 2 factorial. We have two levels of fructose in our medium, no and yes, and then we have two levels of sucrose looked at factorially, and I showed you in the past in a previous video how this can be construed as a little matrix here: no, yes, fructose and sucrose, and what we have is an n of 2 in each of the cells of this design, so n equals 2 in each of these cells. Okay, so we have 8 observations, 8 rows of data here. Here are my actual observations, and what I'm showing here is the mean of each of those cells. And we've talked about how to analyze this. We analyze it, of course, with a two-way analysis of variance. And our model is fructose, sucrose, and fructose cross sucrose. And that last one, of course, being the error. Not the error, but the interactive effect. And of course, when we present our results in an ANOVA table, we would present the error line at the bottom. But what I want to focus on here is how we actually present these results for a data set that's structured like this. And you know, there are actually a lot of ways to present results, and what I want to do is show you how I would present these meanings and how I would potentially make a decision about that by showing you 4 possible ways of presenting these particular means. The first way I'm going to show you is actually an unconventional way. I'll call it the parallelogram approach. And the parallelogram approach works especially in a case like this, where you have 2 factors and you have a no or a yes or an absence or a presence of something. And so we can actually make our x-axis reflect the addition of a factor to the medium. So for example, our first point will be no fructose and no sucrose. And then our second point will be yes fructose and no sucrose, or no fructose and yes sucrose. Or sorry, it'd be y there, y for yes. Okay, so as we go across here, we're going from the absence of a particular factor to +1 level of the factor. And then what we're going to plot over here on the right side of the graph is the presence of both. So yes fructose, yes sucrose, or in other words, +2 factors being added to our growth medium. So here we have +1 factor, here we have 0 factors being added, and we can just plot the means as points. So for example, our mean of our first group, we can see it up here, is where we have no is 1. So let's make our axes here. We're going to have 5, we're going to have 10, and we're going to have maybe 15, just a little bit off the scale. So with our mean of 1, we put a point right there. Okay, and then our first one we want to add, where we're adding 1 sugar to the medium, is where we are adding fructose. And so actually that would be this one down here, and we're gonna plot a mean of 2 right there, and we're going to draw a line between those, which is representing the addition of fructose. And so let's make that a dashed line. Okay. So over here on our legend, our figure legend, we'll make our dashed line plus fructose. And we can see that the mean of our plus sucrose one is 4, so that'll be a little bit higher, right? So we will plot that right about here. And adding sucrose, we're going to symbolize with a solid line. So a solid line is plus sucrose. Okay, so this takes care of plotting 3 of our 4 means. So our last mean is where we have both yes fructose and yes sucrose. In other words, 2 sugars being added. And this is interesting because we can now draw a solid line here, and we can draw a dotted line here. Okay? Why does it make sense to draw a solid line there? Because we are adding sucrose to a medium that has fructose. So this solid line is looking at the effect of adding sucrose when we already have fructose, and this dashed line is representing the effect of adding fructose when we already have sucrose from this starting point. Now, this parallelogram approach, obviously our parallelogram is kind of the null hypothesis, because if these were additive, where would this point be out here? Our point would be right about in here somewhere, and we would have a perfect parallelogram. But that's not what we have. We don't have a point there. What we have is a point here, and so we have non-additivity. So our non-additivity is introduced, and we have a 4-sided figure here, which is not a parallelogram. Due to non-additivity of the effects of fructose and sucrose. Okay, so we kind of have a breakdown. So a parallelogram is our null hypothesis, and then whoops, this mean out here when we add both is much higher than we expect based upon the addition of our single levels of each sugar. Okay, so this is a way to plot effects, and one of the things I like about it is that it really clearly shows that the effect of fructose, indicated by the dashed line, depends on the level of sucrose, right? I mean, if we have sucrose present, like right here, we get a very different effect of adding fructose than if we don't have sucrose there, which is over on the left side, and vice versa. And it shows it kind of equally for both factors. So let's talk about advantages and disadvantages here. So let's think about the advantages of this graph. And again, as I say, this is not used very much, but for certain kinds of analyses, this is the best way of showing the results. So we kind of have a parallelogram as the null expectation. What is a parallelogram? Parallelogram is when the opposite sides are parallel, right? And when we have non-parallel opposite sides, it's very clear that the effect of one factor is depending on the level of the other. And so I like the way it shows that. So we can easily see, and so this is kind of a corollary of this, easily see the non-parallel slopes. They're obvious that this dashed line and this dashed line are not the same, and this solid line is not the same. So it nicely depicts that. And the other factor I like about this is that it gives kind of equal weight to both factors. And when we do a two-way ANOVA, there's not an inherent bias toward weighting one factor over the other quite often. And so if that's the case, if you don't want to emphasize one factor over the other, that's a nice thing. Now there are some disadvantages to this kind of approach. One of the main ones being it's non-standard. People aren't used to seeing this kind of a plot of two-way designs, and that's kind of why I wanted to present it first, because you know, you don't have to follow convention always. Sometimes it actually helps people understand things if you present things in a non-standard way. Now, effects are in fact indicated by lines. And that kind of a line is kind of suggesting that we know something about the values of our y bar, right? We're going to plot y bar. The value, a line being in there indicates that we know something about that response, but we don't actually. We only really know this point and this point. We don't know that y bar would be halfway in between for half as much sugar, half as much fructose, for example, or half as much sucrose in this case of the solid line. So, you know, that's kind of false information. It's that line is an assumption. It's not a true effect. Okay. The other disadvantage of this kind of approach is it's really only effective as a way of showing results when you have very simple designs like a 2x2. You can actually draw these for three-way factorials, and then it becomes even more complicated to sort of explain. But if you have three levels of something, then suddenly it's not a no-yes. It's not the effect of adding something. It's the effect of adding more or less of something. And it becomes harder to interpret these kinds of graphs as soon as you have multiple levels. So I think it's most effective when you have a 2x2, but that limits its utility. Okay, so you may want to write down these means right now, because what I'm going to do is erase this whole page, and we're going to start over and do graph type number 2. All right, so graph type number 2. I would call this, a line graph, okay, of two-way results. So what would that look like here? So a line graph of two-way results would be where we, for example, choose fructose to put down here, and we have no versus yes fructose. We have our y bar over here, which of course every time we plot y bar we really want to write out what it is. So this would be mean p stem segment growth in millimeters, for example. We would write that out. I'm just not going to do all that to take your time right now, but we would have, for example, a dashed line. So we plot our points, and again we have 5, 10, and more than 10. So we have our points would be dashed line representing no sucrose. So we're going from 1 to 2 here. And then we're going from 2 to 13 in the presence of sucrose. All right. So plus sucrose. Okay. Now, I didn't put error bars on the points before, but you know, we really should be putting error bars on our graphs. And as you can see, one problem with these line graphs is that these error bars can overlap, and it's hard to see where the ends of them are, and so forth. I don't really list that as a disadvantage, but if you have a lot of crowded means, that can actually be a problem. Okay, but let's look at this graph. So what does it do? It kind of says the effect of fructose depends on the level of sucrose, right? It nicely says that. The effect of fructose going from no to yes, and a viewer of this graph will always kind of think of it that way. From left to right, they'll think about fructose because you've labeled your axis fructose. Okay, so the effect of fructose, which is representing by the slope of this line, depends on the level of sucrose. So it does kind of nicely depict that. So let's talk about advantages of the line graph. And again, this is actually a fairly commonly used way to show responses. So one advantage is that it clearly shows the differential slope. And that is the essence of what interaction is getting at, is the differential response to the different levels, right? So it is the effect of fructose, which is measuring by these mean differences from no to yes, is different depending upon the sucrose level. We see them both being positive, but one's much more positive than the other. And that's really what interaction is getting at, and that shows that nicely. It is also an advantage of it is that it's a way that people are used to seeing this. So it's a standard kind of presentation. And there is something to be said for using something that people are used to, because they will quickly get the message. Another nice thing, and it's not shown here really, is that it can be used with many levels. So if you have more than 2 levels, you can still make this plot, and it's no problem. Okay? Some disadvantages of this approach. Well, once again, it kind of falsely implies, the lines falsely imply that we know something about, we know the effect of intermediate levels. And so we have to just sort of, make sure that it's clear that we're not inferring anything about these intermediate levels of fructose. Because there certainly is something between our no and our dose that was the yes, right? We have values in between, but we don't actually know anything about them. We don't know that they're linear at all. But we're drawing that line, we're kind of implying we do. So that's false and can be misleading at times. Okay. The other thing I would say is that it emphasizes one factor over the other. And you may want to do that. I mean, it may be that it's more logical that one factor would be emphasized over the other, but if they're sort of co-equal in your mind, you may not want to present it this way, because the logical result statement here is the effect of fructose depends on the level of sucrose. You wouldn't use this graph to say the effect of sucrose depended on the level of fructose. Now you could redraw this graph, right? You could put sucrose on the bottom, and then you could have a dashed line for minus fructose and a solid line for plus fructose. And so you could redraw it with the means in different positions, obviously, and make your point and state it the other way. But it does, either way you draw it, it emphasizes one factor over the other. And I think, that may or may not be a disadvantage depending upon what you actually want to do. Okay, so that's a line graph, quite often used. All right. Also quite often used is a histogram approach. And there are some advantages of this. So what would this look like? Histogram approach could be done different ways, depending upon, again, what we decide to put as our x-axis. So if we have fructose as our x-axis, no, and yes, or absent and present, or however you want to write that. We have our y-bar with our units and so forth. We would, at the no fructose level, be going from, let's see, no to yes. Sucrose would be 4, right? And then we go from yes fructose but no sucrose from 2 up to 13. My widths aren't great here, but you get what I'm saying. So we would have a little key over here which would say minus sucrose. And we would have a key over here which would say plus sucrose. Okay. We would put error bars on this. All right. We could also put, results of an a posteriori test. We could put A, B, A, C, for example. And so that would be a way to present our two-way results, our four means. No problem. But let's talk about the advantages and disadvantages. The advantages first. First of all, this is a fairly standard way of presenting these kinds of results. So having a standard way, people kind of expect to see that kind of a plot and would very quickly be able to interpret it. It kind of appropriately depicts what you know. Now, what do I mean by that? What I mean is we haven't drawn a line that falsely implies we know something about in-between levels of fructose and sucrose. So in that sense, this is a more correct diagram than the line diagram. Okay. Also, we can show many levels. So I've shown a 2 by 2 here, but we could have more bars than that. We could have three bars in each no fructose, or 4 bars in each if we had multiple levels of sucrose, fructose. We could show a lot of histogram bars here, right? So good. That's helpful to be able to do that. Now, naturally, there are some disadvantages to this kind of approach. One real disadvantage, I think, is that it's harder to see the interaction. Remember what interaction is. It's a differential response to levels of one factor depending on the levels of the other factor. So you kind of have to draw a line in your mind here, going from no to yes fructose versus going from no. So you might as well have a line graph, but it's a little bit harder to see that differential response. And in fact, your eye is kind of drawn to what's next to each other. So we have a small difference at no fructose in the sucrose effect, but we have a large difference with fructose. So this almost focuses you on the sucrose effect being small here and being large here, which is okay, but it's kind of harder to see that interaction and describe it. It also emphasizes one factor over the other. And kind of oddly, it does it differently for different people. So some people look at the white bars and compare them, and then look at the shaded bars and compare them. So that would be a differential response to fructose depending on the level of sucrose. Other people tend to compare the side-by-side bars and say, oh, there's a small sucrose effect at no fructose, but there's a large sucrose effect at high fructose. So actually different people favor different factors, which is rather odd, but they tend to look at a graph like this and state it one way or the other. They don't kind of talk about the effect of fructose and sucrose being non-additive here in a co-equal kind of way. They tend to pick one or the other, but what is confusing sometimes is some people focus on the differential response of fructose and some focus on the differential response of sucrose. And if you're not in the same camp as the person describing it in their methods, it can be confusing to you. Okay, so that's actually kind of a disadvantage, I think. But in terms of being correct, I suppose, this is perhaps the most correct way. It's just that it isn't necessarily the most helpful for the reader. So as you can see, there are trade-offs with all these techniques of depicting two-way results. So let's move to the final way of showing them that I want to talk about, and it's not these four aren't necessarily the only ones. I'm just picking out the most common ones. And that is to actually think of these factors as sort of co-equal and to draw them in 3 dimensions. So I'll try to do this here. Not the greatest artist in the world, but let's imagine we have our y bar with our units on the y-axis. And now we have our x1, fructose, and we have our x2 going back into the board, which is sucrose. We have no and yes, no and yes, and we have we're imagining a cube here, right? With the vertical axis being our y and our 2 x-axes kind of going back into the board with x2 and a cross for x1. Right, so we're going to have a 3-dimensional graph here. So our no mean is 1, right? So we're going to go across here and create a little column which has a height of 1. And then we're going to add fructose, and we go up a little bit. So we're going to have a higher column here. And then we're going to add sucrose, and we go up to what, 4? We have a higher column back here. It's getting a little messy, isn't it? All right. And then we have both fructose and sucrose, and we have a really high column back here. Sorry about that. All right. We could even have these shaded, I suppose, depending upon what you wanted to depict. Now, this is kind of interesting. So we could even put the axis out here if we wanted for sucrose. But let's just leave it like that for the time being. All right, so what are the advantages and disadvantages of this nice 2-dimensional graph? So advantage, first of all, like the histogram, it appropriately depicts what you know. You know these 4 means. You don't know what's in between those means. You don't know intermediate levels of fructose or sucrose effects. It's fairly easy to see the nature of the interaction. It's actually a little better than the other one. So fairly easy to see the interaction. In other words, here we can see that going from low to high sucrose doesn't have much of an effect at no fructose, but it has a huge effect at high fructose. And that's actually fairly easy to see that point there, because you have all possible comparisons, and you can think of it both ways, right? You can go left to right, or you can go front to back, and you can make your point either way. Almost equal emphasis on the 2 factors. Why do I say almost? Well, it's because of our human brain. We tend to see things left to right easier than front to back. But, I think we can, if your mind is at all spatially capable, you can sort of twist this around in your head, and you could actually put sucrose in the front, fructose in the back. You can kind of turn that in your mind, and so it's more co-equal anyway than the other way of showing it. Of course, there are some disadvantages to this approach. Practically speaking, it's a little harder to include error bars. Whereas with the other approaches, you can just stick error bars on. Here, it's a little hard, a little awkward. I mean, you could put it in the middle, right? But you have to sort of depict with a dash line or something when it goes down through the surface. I don't know. It's kind of tricky, because where is the top of that graph? All right. I mean, you could put it in the front or back, but that'd be weird. Anyway, so it's a little harder to depict the error bars and show those on there. It's also just harder to produce the graph. Now, there are a lot of graphing programs that will do this for you now, but a little bit harder to manipulate the graph and so forth. And you can imagine how it may be harder to see certain means. depending upon their relative value. So if we had, for example, a tall column in the front and a short column in the back, there are some columns that could be completely invisible, right? And you'd want to be able to turn it in 3 dimensions in order to show what you want to show. So for certain kinds of mean comparisons, these disadvantages really outweigh the advantages. But for some straightforward results where you want to take advantage of these advantages, it's actually not a bad way to go. So what I would say as a conclusion to all of this is to try to be flexible in the way you illustrate your two-way results. Choose the way that best supports the results statement that you're putting into your paper so that you can make your point. Because that's what graphics are all about. You want to, in a single visual, get the point across about the interactive effect. And whatever mechanism does that best for you is what you should use. All right, that's it for today. Graphing.